Now, today is nothing new at all, just kind of a lot of things you already know. We do it one time. Again, the unit circle is a great time saver on these, and if you know the unit circle, it actually makes every question more understandable, let alone faster. Okay? Sometimes when we have faster ways to do something, we lose the math in it. But really, knowing your unit circle is knowing the math, and then once you know the math, you can just pull from it, okay? So let's go right to an example to see how this is done. Now, first of all, a thing that you're going to be seeing is how do you do something like this algebraically? Now, the first thing you want to do is you want to make this thing equal 0. So it would be 2 sine squared x minus sine x plus sine x, I should say, minus 1 equals 0. Now, what you have to realize is this is exactly, we're going to do this exactly as if it was 2x squared plus x minus 1 equals 0. So don't let the sign throw you off. And just remember that this means the same thing, right? If you take that 2 out and you put it out there, that means the same thing. And that's what we would put in our calculator. So what we're looking at is we're looking for two things that add to 1 and multiply to negative 2. This is a type 2 decomposition. Those two numbers would be 2 and negative 1. So this would be 2 sine squared x plus 2 sine x minus 1 sine x minus 1 equals 0. Remember what we do next is you put brackets around each. So what can we pull out of the first set? 2 sine x, right? Leave me with sine x plus 1. The next one, I will take out a negative 1, leaving me with sine x plus 1. Okay? That's always good news. When we get the same thing in brackets, I will take a sine x plus 1 out of both sides, leaving me with 2 sine x minus 1 equals 0. Okay, so this isn't new at all. You guys have been doing these for like 3 years now. So just a simple type 2 decomposition. Now, what you have to understand, if this whole thing in brackets equals 0, 0 times this would equal 0. So if this equals 0, the whole thing would equal 0, right? And also, if this whole thing equaled 0, it would all equal 0. So what I do is I actually now do it in two separate equations. So I will always do a squiggly line right here. And I'm just going to work with the 1. I'm going to do, well, when does sine x plus 1 equal 0? Because when it equals 0, it makes it all equal 0, so I can do with it separately. So then I do a little math. When does sine x equal negative 1? I draw my coordinates out, or my graph. Where does sine x equal negative 1? Where is it? Okay. Now, if you're using the unit circle, this would be your work right here. Because people say, well, I know the unit circle, so I just got it off there. No, I want to know where you found it on the unit circle. Now, do you have to draw the entire unit circle? No. What I want you to do is show me that you understand I know where it is. Not I looked over someone's shoulder and cheated off them. Okay? Actual work. What happened in your head, get it down on paper. Because you can't play the old, I did it in my head. Because if I had a question worth 3 marks and all I had was the answer, you're like, I did it all in my head. Well, too bad. You're getting 1 out of 3. You need to show me the work. Okay? So this is 3 pi over 2, right? Let's do the other side. Let's do the algebra. When does 2 sine x minus 1 equal 0? We'll add 1 to both sides. So that's when 2 sine x equals 1. And then I'm going to divide by 2. When does sine x equal 1/2? Okay, again, draw it. When does sine x equal 1/2? Pi over 6 and 5 pi over 6. See, I'm showing my work. I know where it is on the unit circle. So pi over 6 and 5 pi over 6. Now, what is the long way to do these? Well, when does sine x equal -1? So then I take the inverse sine of 1, remember? Then I get the reference angle. And then with the reference angle, I draw the reference angle, and then I go find the rotation angles. That's what you have to do if you don't know your unit circle. So the actual question answer is when x equals, and all I'm doing is putting them in order of rotation, pi over 6, 5 pi over 6, and 3 pi over 2. That's the answer. If you put any of those in there, your equation will equal 0. So the next question is, how would you do the general solution? Do you see how we have no propellers in here? So there's no short form for this. So I'm just going to say, when x equals pi over 6 plus 2n pi, 5 pi over 6 plus 2n pi, and 3 pi over 2 plus 2n pi. N is in the integers. So if you look in there, not one thing is new. You don't have to learn any new skills. Maybe you have to learn an order. So if I was making this as a study sheet, this would be a really good example to have on there. Number 1, make it equal 0. Number 2, factor it. Then once you factor it, and it's in the two little things, do a squiggle, do left side, do right side, get your angles down, and then put them into general form. Okay? Let's keep on going here. Now, look at this one. Now, if you ever get messed up, think like this. So maybe get rid of the sine x for a while, or sine a, and just do that. Now, how would I factor that? Come on, you guys. 4x squared minus 1. How do you factor that? The difference of squares, right? So that would be 2 sine x, or sine a minus 1, and 2 sine a plus 1 equals 0. As soon as I have it factored, what goes next? Do your squiggly line and do the left side, then do the right side. So when does 2 sine a minus 1 equal 0? Well, bring the 1 over. That would be 2 sine a equals 1, right? And then divide the 2. Sine a equals 1/2. When does sine a equal half? Talk to me. Pi over 6 and 5 pi over 6. So the amount of work you put into learning your unit circle will pay off every time you do a question. If you can take 2 minutes off a question, and you have to do 10 questions, that's 10 minutes you save, and I'm only asking you to spend 2 minutes on it tonight and memorize it, right? Every night, can you do your unit circle? Can you draw the entire thing? Okay, next one, I'm going to do, when does 2 sine a plus 1 equals 0? Bring the, that's 2 sine a equals -1. sine A equals negative 1/2. So when does sine A equal, oops, what happened here? Yep, nothing happened. Okay, when does 2 sine A equal negative 1/2? 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6. So the general, in order of rotation, would be pi over 6 plus 2n pi. 5 pi over 6 plus 2n pi. 7 pi over 6 plus 2n pi. And 11 pi over 6 plus 2n pi. N is in the integers. Yep. Yes. Okay. Now the book didn't even see that. Okay. But you can see that you've got two propellers here, right? So you could take these two and put them together, right? And then you could take these two and put them together. So that would be pi over 6 plus n pi. And 5 pi over 6 plus n pi. N is in the integers. Now it's n pi because if I was here, I need, watch, if you were here, you just need pi to get over to here, right? And then pi to get back, pi. Okay, this one here, if you started here, pi gets you here, over here, over here, over here. Okay, so when it's a propeller, you're going to have n pi's. I hate the word always in math, but if you got a propeller, you can use n pi. If I come up with a case that doesn't work, I'll let you know. But it doesn't happen in 30-1. Okay, we're going to do two more. These are quick, but have little quirks in them. Okay, now, how about this one? What can I do to factor it? Come on, you guys. Think of that as x cubed, or x squared minus 3x minus 28. Okay, so I got to look for two things that add to give me negative 3 and multiply to give me negative 7. What are they? Okay, I'm going to go negative 7, 4. I know, sorry. Yes, that should be negative 28. So then I'm looking for, I'm going to go cosecant x squared, no, sorry, cosecant x minus 7, because it's just a type 1, right? And cosecant x plus 4 equals 0. So once I have it factored, draw your squiggly line and do them separately. Now, another thing you got to watch out for is this. This is a restricted domain. So just be careful, and I'm not asking for a general equation here. Okay, so this is when cosecant x minus 7 equals 0. It's when cosecant x equals negative 7, or positive 7. And what on earth am I going to do at this point? Yeah, this is 1 over sine x equals 7. Now what do I do? Sine x equals 1 over 7. So what you want to do now is you're going to have to find the reference angle, right? So seconds sine 1 over 7. And since sine is positive, I will be in 1 and 2, right? What's the reference angle? In degrees. Make sure you're in degree mode in your calculator. 8 degrees. Okay? So this one we have to do using our reference angles. So what are my answers? Let's write them right underneath. What are they? 8 degrees and 178 degrees. 172 degrees. Okay. Now, let's do the other side. Cosecant x plus 4 equals 0. Cosecant x equals negative 4. And do you guys at this point know that just sine x would equal what? Negative 1/4. Good. Okay. Now, where is sine negative? 3 and 4. Oops. I'm going to cross it out. They are negative there. Okay. So make sure you put in negative, or don't put in second function sine, or second sine negative 1/4, just positive 1/4. You only put the absolute value in. What do you get as an angle? How much? 14. Now, just the fact that I'm working in these two quadrants is not needed, is it? Look. So this, what would we say, is not in domain. So therefore my answer is 8 and 172. Okay, a little more. Now this one is restricted domain. Okay, we're looking for two things that add to give me 5 and multiply to give me negative 6, right? What am I looking for? Okay, so 2 cos squared theta plus 6 cos x, or cos theta I should say, minus 1 cos theta minus 3 equals 0. Put brackets around this, brackets around this. I can take out a 2 cos theta, leaving me with cos theta plus 3. And I can take this out, negative 1 out, to be cos theta plus 3. Okay, and then I'm just going to take out a cos theta plus 3, leaving me with a 2 cos theta minus 1 equals 0. So now I just do the two separate sides. So, when does cos theta equal negative 3? I should put this in. Cos theta plus 3 equals 0, and then I did minus 3 to both sides. So when does cos theta equal negative? Where's cos negative? Two and 3, right? So what's second function, or second? What are we getting? Are we getting error? Cos and sine can never be greater than negative 1 or positive 1. It's always in that domain. So this side, there is no solution. Okay, and that's why we're doing this one, because sometimes you're going to come up with those. And if I don't do an example in class, I'll got 30 questions on my desk. Now this would be when so 2 cos theta minus 1 equals 0. When does 2 cos theta equal 1? When does cos theta equal 1/2. Okay? So where's cos theta a half? At, we don't know. Pi over 3 and, huh? Yeah, pi over 3, sorry. Yeah, 2 pi over 6. Pi over 3 and 5 pi over 3. Just 10 pi over 6, right? So that's pi over 3 there. And all the way around is 5 pi over 6. Now, I guess we need to actually look at my domain. Because my domain, if you look at it, goes between 0 and pi and 0 and 2 pi. Or 0 and negative pi. So the first answer would be pi over 3. What would the other answer be? Negative pi over 3. Because this is negative pi over 3. Okay? So these two questions were on a restricted domain. So we'll do 1A, C, E, dot, dot, dot. 2, 3, 4, 7, 8, and 11 to 13. So 1A, C, E, G, dot, dot, dot. It's 2, 3, 4, 7, 8, and 11 to 13. Okay, so we'll be working on the unit circle. I got to do everything I can to make sure you know that unit circle perfectly for the unit exam, the replacement exam, and the diploma exam. And I told you that the trig unit you need to know the most stuff for. So I hope by now you don't think I was lying. Because we got a lot more stuff to know. And a lot of stuff that we have to remember from the last unit. The unit circle being one of them.